Welcome to clickmyproject.com.
Dynamic base station on and off strategies for green cellular network. A cellular network consists of three main elements: a core network that takes care of switching, base station providing radio frequency interface, the mobile terminals in order to make voice or data connection. In telecommunication system, 4G is the fourth generation of mobile phone communication technology standards. In MIMO downlink, the users are scheduled. After the users are scheduled, we have to discuss about for the dynamic base station on and off strategies for 3G mobile cellular network. We implement the switched based on and off strategy energy saving algorithm for both green cellular network. We formulate a general energy minimization problem pertaining to base station switching that is known to be a difficult combination problem and requires high computational complexity as well as large signaling overhead. We propose a practically implementable switching on and off based strategy energy saving algorithm, SWES algorithm that can be operated in a distributed manner with low computational complexity. The flow consists of 5 modules: network formation, traffic calculation, threshold, SWES algorithm, and performance solution. In network formation, network consists of a set of K cells that have the same coverage radius R and traffic load that has the periodic pattern. Downlink communication in mobile internet from the base station to user equipment. Packet-based data traffic model is used. The spatial traffic variability by file size for different users. Signal will be selected in the base station based on the base station rule. The next block is traffic calculation. The traffic value is calculated using the number of users and the signal strength information. Traffic is directly proportional to the energy consumption. Traffic load of location x at time t, y of x comma t equal to lambda of x comma t divided by mu of x comma t, where lambda is a traffic arrival rate of location x at time t, where 1 by mu of x comma t equal to average file size of location x and at time t. Then we go for threshold block. From the traffic value, we can calculate the threshold value which minimizes the energy consumption. Threshold value used to shut down the base station when the traffic of the particular base station exceeds with this value. The threshold value is also ensures that the switching of the base station does not affect the network stability and the quality of service of the user. The next is SWES algorithm. If once the threshold will be set after the SWES algorithm determines the base station is switched on and off for the particular time. SWES algorithm is in which the base station get turned and off one by one whilst ensuring users quality of service. It has two procedures: switch off and switch on. In switch off procedure, from the previously calculated threshold value, we take the decision either to switch on and off the base station. If the traffic value of the particular base station exceeds the threshold value, then it sends an request to other base station with request to switch off RTSO. The other base station check their threshold values. If it is satisfies, then they send acknowledgement to that base station. Then the requested base station shares its load to all other base stations. If it is not happen, then this message will be rejected. The next one is switch on algorithm of SWES. To implement the switching on and off switch on algorithm could be to reverse the switching off algorithm. The basic concept of switching on algorithm is that the base station should be switched on when the system load reaches above the threshold value. However, the turn off base station cannot make a switching on decision by itself because it does not have information about the current system load. After this SWES algorithm, then we go for the performance evaluation block. In performance evaluation algorithm, the proposed algorithm minimizing the total energy consumption is less than the 10% in the real-time traffic condition. To guarantee the quality of service of user equipment, a base station should assign a certain amount of resource depending on user's traffic load. Simulation tests shows that our proposed SWES algorithm performs better than the existing algorithm in literature to minimize the energy saving ratio. Open the source code folder and run main m file. New window appear. Initially form the network by pressing this push button. Traffic is calculated for the 3 base stations. The base station 1 has 49 users and 2 has 68 users and 3 has 97 users. After that we can call the switch on off algorithm. The base station 1 has the less value, so it can send the request to the base station 2 and 3. The base station 2 and 3 sends response to the base station 1. After that the load is shared to remaining base stations. Then we can call the switch on algorithm. base station 2 sends acknowledgement to base station 1, and base station 1 is replaced to that base station 2, and load is shared between three base stations. And then we can call the performance evaluation of the proposed algorithm. This is the traffic load comparison graph. Load is varied in every time in a day is represented here, and energy saving ratio of our proposed algorithm. This is the energy saving ratio of social algorithm, and this is a system load. System load is decreased, and then the distance to neighbor base station. This is our proposed method, and the number of neighboring base station is here. From this I conclude that our proposed method saves 10% more energy than the existing methods in the literature. Thank you.